Hi, this is a video to explain the need for dynamic arrays in Java. The problem with simple arrays is that these arrays do not grow and shrink as the size of the array increases or decreases. So if I create an array of size 3, and once the 3 items are populated, I cannot add any more item. I cannot add a 4th item. That's wrong. What I would like to do is, I would like to have an array that grows and shrinks as the size of the array or the number of items in the array changes. For the time being, we'll only grow the array, but we can also shrink the array if required. So we can resize the array if we want. The concept is fairly simple. We can create an array that has, let's say, 3 items. Now, once the 3 items are added, what it's going to look like is this. In the memory, your array reference is there. Your 3 items are somewhere else. The array refers to that section of the memory. What we can do is, somewhere else in the memory, when you want to add a 4th item, you can create a new array which has, let's say, 5 items. Then, so the first step is create a bigger array. The second step is copy each item of the old array into the new array. And the third and final step is the original array A should now refer to the new array as well. So temp. What this means is that the old array that contained 3 items is no longer referenced, and any unreferenced object in Java is freed up. So the memory is free. A now refers to the bigger array, and you can see that you can successfully add a 4th item and a 5th item there. What happens if you want to add a 6th item? You repeat the same process again. You create a bigger array somewhere else containing, let's say, and so on and so forth, let's say 10 items if you want. Copy all items of array A, and let's say this is 6 and 9. Copy all items from the old array into the new array and re-reference your original array. So that's how we can resize an array in Java. What I've done is I've created a simple class that does this for us. So here I have a class that stores an array inside it. It also keeps a track of how many items are there in the array right now. And every time the array has to grow, it will grow by 5 values. In the constructor, you instantiate the array and say that it contains 0 items so far. When you want to add an item to the array, the first thing you have to check is if size, which holds the number of items added to the array already, equals a.length, which means that the array is full because all items of the array are occupied. If that's the case, then you grow the array in the method, using the method that I just described. Once you grow the array, the first size indices are occupied, which are from 0 to size -1, and therefore the first free item of the array is at index size. to which you assign the value item. Now that you have one more item in the array, you increase the size. The most important method, of course, in the class is how do you grow the array. I've got a nice simple statement here that it's growing. So when we run the program, you can see that it actually grows. Step number 1, create a bigger array. How big? The current size plus grow size, where grow size is 5. So in my example, it will grow by 5 every time. Second step, as I said, copy all items from our array into the temporary array. And the third and the final step, re-reference your array to point to the new, bigger array. That's all. This is my client where I create a dynamic array object that initially has, let's say, 4 items. I add 20 items to the array. So I'm adding item 1, item 2, item 3, and so on and so forth. Let's add the value that we are adding, let's say, is 10 times I. And we display the array. What you'll notice is when I add an item to the array, each time the number of items in the array equals a.length, it will grow. So it will invoke the grow method, which will say that it's growing. Let's run this much. You can see, since I created the original array to be of size 4, the first 4 items are added. But when the fifth item, when you try to add the fifth item, it has to grow because all items of the original array are occupied. So it grows by 5 values, and the next 5 items can be added directly. When you try to add the 10th item, it has to grow again, and you can add 5 more items. When you try to add the 15th item, it has to grow again, and when you add the 20th item, it has to grow again. I've also added some other methods like getSize, which simply returns how many items are there in the array, isEmpty, which checks if the number of items in the array are 0, and if it is the case, returns true, and remove. So you can remove an item at an index. Now how you do that is when you try to remove an item, all items after that need to be pushed to the front by 1 space. So from next index onwards to the end of the array, each item goes 1 place back. Since we've removed an item, we decrease the size by 1. So we run this again, and you can see I'm removing a random item from the array every time. So my 20 items are there in sequence, and in the first go, the item 160 is removed. In the second go, the item 60 is removed. In the third go, item 10 is removed. In the fourth go, it's item 130 that is removed, and so on and so forth until the array becomes empty. My two-string implementation is fairly simple. If the array is empty, return empty brackets. Otherwise, add each item to the result followed by a comma. Remove the comma from the last, after the last item, add square brackets and return it. I've also included a method getDetails. So instead of toString, if you display array.getDetails, you will see the actual details of the array. So over here you can see that for the first 4 times the size of the array is 4, but after the first item is added, 3 items are still available, 2 items are available, 1 item is available, and none items are available. Similarly, after adding the 5th item, there are 4 items which are available, which toString doesn't display, because toString only goes from I equals 0 to I less than size, which is how many items you have. So that's how you can show the details of the array. So that's how you create dynamic arrays. There are some other methods in my class, like adding an item at a specific index, or removing a specific item, or removing all occurrences of a specific item. I'll leave this source code in the description so you guys can take a look at that. Thank you.